Okay, this is going to be our second video that reviews volumes. There is a very, very good chance that one of your 6 AP questions is going to be concerning a volume, a shell, a disk, a cross-section, and most likely it will be find the area on step 1, find the volume on step 2, and then find the volume with cross-sections on step 3. That's almost always the way it goes. So what I would like for you to be able to do on test day is go straight to that problem, get hopefully all 9 of those points, and then move on and spend your time on more difficult items. So here we go. This is disk and washer method, and we're going to do an example that's washers because very rarely does the AP test give you a disk. It's just a little bit too easy. The difference, in case you've forgotten, a disk method would be to take a shape like this and rotate it around the x-axis to make, a little football shape. If the entire border of the shape is touching the axis around which it's spinning, that's a disk method. There's no empty space. You're making just a solid shape. A washer method, like the one we're going to do, takes some shape that doesn't border the axis and spins it around, and you create all this open space in the middle. You create some sort of like donut type shape with space in the middle, and it's called a washer because a washer is like a disc with a hole drilled out of the middle. Looks kind of like that. So we're going to focus on washer method because that's most likely the one you're going to get. If you happen to get discs, that's good. That just makes it a little bit easier. Okay, so let's start this process. We've got a graph. This is going to be a calculator question. We've got a graph that's enclosed by natural log of x plus 1 and 5x minus 2x squared. So what you'll want to do probably is get a picture of that in your calculator. So here's a picture, and I'm going to zoom in so I can get a better idea of what's going on here. All right, so here's the natural log of x plus 1, and then next will be the quadratic function. So this is the area that I'm going to spin around. I'm just going to sketch it as I would if I were answering this on paper. It's in the first quadrant. I've got a natural log like that. I've got a quadratic like that. So this is my region. So on your AP test, you might be given a region or you might be given the functions. Most of the time, they'll give you a picture of it, and they'll say something like, this is the region R, and ask you to do things with R. So what we're going to do with R is we're going to spin it around y equals -1. The axis of revolution is down here. So I did that not only to, I could have spun it around the x-axis and still had washers because there's empty space between the region and the axis. But I moved it down to do what do we do if we're not spinning it around the x or the y-axis? All right, now here's how I think of washer method. For shells, if you recall, we do 2 pi integral radius times height. Because 2 pi times radius times height with a little bit of thickness, dx or dy, that's the volume of a shell. All right, it's a different kind of geometry for a washer. A washer or a disc is basically a circle with some thickness. So it's really a cylinder. Most cylinders you think of as like a Coke can, kind of look like this, but that's all we have. It's just that it's really short and wide. So if you have a shell, you've just taken out some of the middle. The volume of a disc slash washer is the area of the circle with some thickness. Pi r squared with some thickness. So if you think about this thing as in terms of a cylinder, it's pi r squared height, really. But the height of these is just the thickness, so that's taken care of by the dx. So all you need to remember for a disk method, pi on the outside, integral of radius squared with thickness. For a washer, which is what we're going to focus on, pi on the outside, big R squared minus little r squared on the inside. This is what you need to remember, one of these. A very common mistake, by the way, is to use this instead of this. All right, we don't want that. You need to square them both separately. has to do with our order of operations. All right, so let's take that little formula and see what we get. With this particular area, this region R, I'm going to spin it around. The rectangles, whenever you're doing discs or washers, not shells, when you're doing discs or washers, the representative rectangle, or the rectangle that's going to be spun around the axis, needs to be perpendicular to it. So you can imagine this rectangle spins all the way down. This would just be a kind of a weak sketch, but it ends up looking sort of like that. That's pretty bad, but you get the idea, I hope. My point is, you need to make it perpendicular to the axis to make a disc or a washer. So pi on the outside, everything is in terms of x in this case. If your rectangle is vertical, everything's in terms of x. And what do we need to know? We need to know where we start and where we stop integrating. So I'm going to start at 0, and here's my next little struggle. It's not anything we can't handle. We need to know where to stop integrating. Where do these two things cross? So if you go back to your calculator, the question is, where do they cross on that right intersection? If you want to know anything about a graph, second trace to get to the calc menu, that's where you want to go. Choose 5 for intersect. It's going to ask you which two graphs, and you probably only have 2 graphs on your screen, so you can just hit enter and enter. And then for the guess, which you do need to get kind of close to so it doesn't give you the other intersection, get close to the intersection with your cursor and hit enter, and it's going to tell us where they cross. They cross at x equals 2.2374732 and y equals some number that I don't really care about. So the number that I care about is x equals 2.2374732. I think I got that right. So sometimes you could say, like, let a equal 2.2374 whatever, and then just go from 0 to a, but you can just write the full number up there as well. Don't round it off. I would strongly encourage you to not round off anything until the end of these problems, because it could affect your final answer. So now that's my, this is just pi r squared with thickness. Because it's washer, I have 2 separate radii. The first radius, the big radius, goes from the axis of revolution to the further of my 2 graphs. When you're doing washers, all you're really doing is 2 disk methods and subtracting, considering the smaller one to be empty space that's like being drilled out of your solid. So you have 2 separate radii, and the big one just goes out to the further graph. So how far is that? Well, this distance, this portion of that distance goes from the axis up to a graph. That distance has 2 names. It's either called y, or it's called what y equals in terms of x. So that graph is either y, or what was the function? It was 5x minus 2x squared. Either one of those stands for the vertical distance up. And since I am in all x mode here, everything is x. This is x equals 0. This is x equals 2.23. My vertical rectangle says everything's in x mode. I want to use the 5x minus 2x squared. So my big radius is 5x minus 2x squared. That blue distance, however, is that plus 1. Stop those parentheses. 2x squared plus 1. That's big R, and that needs to get squared. All right, that's what I'm filling in right here, big R squared. My big radius is the upper function plus 1. Now I need to subtract small r squared. Small r is right here. It goes from the axis of revolution up to the shorter of the 2 graphs. Again, this portion of that is either called y if I was in y land, but since I'm in x land, I call it what y is equal to, which is the natural log of x plus 1. My little r, however, has this distance as well, which is that plus 1. All right, little r squared. The brackets are just to group those things so that dx applies to it all. But this is the expression that will give us the volume when rotating that shape around the line y equals -1. All right, so it kind of looks crazy when you're done, but if you remember these, if you remember that it's really just a cylinder and it's all you're doing is pi r squared with thickness because it's a circle with a little bit of height, then these shouldn't be too bad. So let's finish it up. In our calculator, we need to figure out that integral. So Math 9 is where we integrate things. I need to integrate that function that is two different parts both being squared. So 5x, let's see, my function, I need parentheses for the first thing that's getting squared. 5x minus 2x squared plus 1, quantity squared, minus for the little radius. The little radius, that was the natural log, and that starts its own parentheses, so I do x plus 1 to close out the natural log, plus 1 to finish off the radius, close the second thing squared and square it. So that's my function. All right, sometimes the hardest part is getting these things entered in the calculator. So you'll probably get half credit on your test for writing it out and then the other half for the final answer. So practice getting these things put in your calculator correctly. The second thing you type in after the comma is x, which means we are integrating with respect to x. And we are starting at 0. And we are finishing at that other value, which was 2.2374732. 2.2374732. I might have missed some of those digits along the way here, but I think that's it. And then close your FNINT call. I think that looks pretty good. All right, it's got that long decimal, but that doesn't really matter. You can write that number down and type it in your calculator. So let's see. Final answer of about 18.5, and usually I think 3 decimal places, so let's call it 18.521. All right, so there you go. That's a nice solid calculator AP style washer question, something that it's very possible that you would have to figure out on your AP exam in a couple months. All right, so that was part 2 of volumes. We'll do cross sections next time, but shells, washers, and cross sections need to be automatic. You've got to know those going in. Like I said, get those easy points and run. All right, so hope you've enjoyed it. Young out.